imagine that you're a professional soccer player. So you're sprinting at top speed, dribbling with the ball on your feet, and then at the right time, you kick the ball with either your left or your right foot, you don't mind, and you score the goal. And so this is perception, perceiving and acting in motion. And that's what we study in the sensory motor lab.
Take your seat, please. In the robot lab, we test how participants learn new movements. By, for example, manipulating the information that they see with respect to the information that they feel about their body. And in this experiment, Yvonne, my colleague, she moves with the cursor, the red dot, that represents her hand, out to targets on the outside. Then suddenly the cursor will move 30 degrees off the target. What we usually observe is that within a couple of trials, participants learn to correct in the opposite direction, and in this way we can learn how people learn sensory motor control.
This is the motion platform, so it's a very intriguing setup, but it's combined with this big display by which you can create a virtual reality environment. We can measure their eye movements, we can measure their head movements, their arm movements, as well as their brain signals in order to understand the neural mechanisms that are involved in perception and action. The participant can also control this motion device actively themselves, so we can move the participants as we want it, but the participant can also move the system him or herself. And that can all be realized in this setup. So it really helps us address questions that not many labs in the world can ask.
Some people use their visual information more, while other people use their sense of where their body is in space.
If we understand the basic science and we understand the principles, then perhaps we can also translate them to situations when things go wrong. For example, in particular diseases, particular patient groups.
The research that we do, it has many applications. For example, in rehabilitation, but also in sports. If you know what information they need to perform better, then you can develop training programs around this.
We also try to understand the principles of human functioning and try to bring them to, for example, robotic devices. Perhaps we can implement those ideas as neuroware in robots, or neuroware in, for example, self-driving cars, which are also kind of robots. And so these are gains that I think society really gets from this type of research.
Participants think it's really fun to participate in our experiment because they feel like video games. Often you can score points.
I think if you're a participant, there's also lots to gain. We measure the brain activity, and after the experiment, participants will be debriefed. So you also learn a little bit about yourselves.